Hey everyone, in this video we're going to be using Unity ML agents to do machine learning and specifically reinforcement learning using PPO to train penguins that are going to learn to swim around in their little environment and pick up fish and then bring that food back and feed their babies. So we're going to do a code along exercise here. So this is a pretty long video. We're going to code along in C# using Unity, of course. So it would be very helpful and recommended that you have some Unity experience prior to this and some programming experience. And I'm going to provide all the 3D meshes and scripts for free, so you can download those. If you follow the links in the description, you'll get not only those resources, but also I'll be able to provide any updates. Because this is a project that is still in development by Unity, there will be changes and they may break things in subtle ways. So it's always a good idea to check those out first. I'll also make sure to provide an outline in the description of the video. So because this is so long, maybe skipping around in there isn't as easy to do, but you can just click into specific sections if you need to resume this video. So with that, let's get started. The first thing you need to do is find the Unity Technologies ML Agents GitHub page, and I'll make sure there's a link to that in the description. You need to come here, and the first thing I recommend you do is scroll down and start reading about it. If you haven't had any exposure to it at all, I think it's really helpful to check out some of these descriptions. There's a lot of cool little examples in here that you can learn from. But in order to install it, you need to follow the installation instructions. And so come to this section and go to the documentation home, and then follow the instructions here in particular. The installation, and the basic guide. You don't need to do Docker or Jupyter Notebooks, but definitely bare minimum do the installation. And then I'd recommend you do the basic guide because that's going to help you make sure that your environment is set up and working properly. And I just want to kind of show the installation really quick. You'll need Unity. I am running on the most recent build that's quite a bit newer than 2017.4. So that's the key is or later. And I also am on Windows, so I followed the detailed Windows users guide. And this gives you installation instructions for Anaconda, which I'll be using, and how to set up that Anaconda environment and how to clone the Git repo, all this stuff. And in particular, I do want to point out two things toward the end here. This section looks like it's optional for you because you're not it says if you intend to make modifications to ML agents, you should install these packages. I found that mine didn't work if I didn't follow these instructions, so I would just recommend going through and doing that. And then you can skip this step about GPU training because GPU training is really optional, and I believe I read something in the issues for this repo that said that it wasn't optimized to use GPU anyway. So once you have that installed and running, then let's take a look at, actually, there's some installation instructions here that say that you should use the git clone to get your directory. You don't actually have to do that. And the way that I did it was I went up to this top level of the directory and I went to releases. And this video is specifically using ML Agents Beta 0.8.2. So if you click on this, or rather if you come down here to assets underneath this one, then you can download the source code in a zip file. Now, once you have that downloaded, this is my version of that zip directory, ML Agents 0.8.2. Open up Unity, and I have Unity version 2019.1.10f1. So if your UI looks a little different than mine, then that might be why. We are going to first off import from this directory. We need a couple things. So go into Unity SDK, Assets, and then we want to import the gizmos and the ML agents. We won't actually be using the gizmos, but I believe some of the examples do. So you can click and drag those into Unity. Seems like it's just taking a minute here. Okay, and once you have this imported, then open up ML Agents, and you can see a few things in here. There's a lot of examples, so if you're looking for example code and example scenes, then they live in here. And then the scripts, there's actually quite a few scripts that we're going to be inheriting from. There's the original C# classes. These things, we're going to be making an academy and an agent, for example. So these are where those base classes are. All right, so in my previous ML Agents video, I had a couple people griping in the comments about how it was just moving things around in the Unity interface to set up the scene. So this time we're going to switch it up. We're going to do code first, and then we'll come in and we'll set up the scene after we have all our code written. So right click in here, and we're going to create a new folder. We're going to call this scripts. Open that up, and then we're going to create 5 empty scripts, and then we'll start filling those in. So I said 5, I meant 4. Create C# script. First one is PenguinArea. Second one is PenguinAgent. Third one is going to be PenguinAcademy. And the fourth one will be fish. All right, so now we're going to open up PenguinArea and get started with this one first. So up at the top, we want to add a couple of using statements. So we're going to be using ML Agents. That's going to allow us to use a lot of this base functionality that comes with the library. And using TM Pro. That's Text Mesh Pro, which we will be using to display some award text. Next, we don't want to inherit from mono behavior. We want to inherit from area. And then we want to clear this out. So let's define a few public variables that we'll use in the inspector. Public PenguinAgent, and we'll call it PenguinAgent. Public game object, penguin baby. Public fish, fish prefab. And public text mesh pro, and we'll call this cumulative reward text. So just to explain these really quick, this will be the penguin agent, obviously. This one's going to be a baby that the main agent is going to feed. It's not going to have an actual script on it. It's just going to be sort of a target, so we don't need to have a specific script or name for it. The fish prefab will get spawned by this class, so that's why we need a prefab and not an instance of it in the scene, as opposed to these two. And then finally, the Text Mesh Pro is going to display our cumulative reward as the penguin learns and acts in the environment. Next, we need a couple that we're going to hide in the inspector. This is because we want them to be public and easily accessible, but we don't want the user, basically us, to start messing with them because we'll be modifying them completely from code. So we'll add in square brackets, hide in inspector, and then under that we'll call it public float fish speed. And we'll default that to 0. We don't want our fish to move at all at first. Now we need another hide in inspector, public float, and this one's going to be called fish reward. So, oh, I misspoke. This one is not going to be called that. It will be called feed radius. I was working from a previous version of the code. So these are actually going to be our starting values, our starting parameters for how this thing works, and we'll modify them later. I'll explain them in more detail. Next, we need a private list of game objects, and we'll call this, game object, and we'll call this fish list. This will keep track of all the fish that we spawn in the environment. So now the first function that we need here is a public override, And as soon as you type override and hit enter and space, it's going to suggest the different things that you can override. So we're going to override reset area and remove this base command here. So anytime we reset this area, we want it to do a few things. And there's going to be a couple functions here that do these things to sort of separate that out. First thing we want to do is remove all fish. Second is place penguin. So we're going to pick this penguin up and place it somewhere in the environment. Then we're going to place baby. So same idea. And then we're going to spawn fish. And we're going to spawn 4 of them. And we're going to use the fish speed as well here to specify how fast we want them to move. Now here's a little tip. You may have known that if you're in Visual Studio, you can right-click, go to Quick Actions and Refactoring, and generate this method. So we're going to generate this one first. And what it does is it places it right beneath the method that you're already in. So if I do start at the bottom, then it'll create them in order. So I'll right-click on this one, generate it, right-click on this one, generate it, and right-click on this one, and generate it. So now all these show up in the order that they're called, which is helpful for us to sort of see them chronologically. So the next one that I just want to add before we start implementing these is a function that's going to remove a specific fish from the environment, because as the penguin moves through the environment and runs into fish, he's going to have to remove those, sort of destroy that fish as he consumes it. So we need a way to access this list of fish and delete a specific fish rather than just removing all of the fish. So we'll create a public void remove specific fish, and that's going to take in a game object, fish object. And then inside this, we want fish list dot remove fish object, and then destroy fish object. So then we're no longer keeping track of it, and then we can destroy it, and it's removed from the environment or from the area. Actually, there's one more, public, and we're going to call this one public static vector3 choose random position. Okay, so this one is going to be used outside of this class as well, and that's why we call it static. It's not going to access any of the variables in this instance of the class. It's just going to do some calculations for us, and we'll use it inside of the fish script as well, and that's why we're creating this as static so that it can be accessible there. And choose random position is going to take in a vector3 called center, and that's going to be the center position. And any position that we choose around it is going to be centered on this point. Then we are going to use float min angle and float max angle to determine what the angle will be when we choose a random position. So it might be between 0 and 90 degrees, for example, or 0 and 180 degrees. The way that our area is shaped, it's actually in a circle, and so choosing a random position on the circle is going to make sense for when we start spawning things in the environment. And finally, we're going to have an option to spawn things between 2 different radii. So essentially choose a random distance from the center, but limit it between 2 different values. So float min radius and float max radius. Now, inside of this choose random position, we need to pick this random position. So we'll start off and we'll set a float radius equal to min radius. So we'll start off by just setting it to the minimum radius that was specified. Next, if max radius is greater than min radius, essentially we don't need to change it if the max radius isn't bigger than the min radius. Something's up if it is. So we'll set radius equals unityengine.random.range between min radius and max radius. So this will choose our radius. I add this UnityEngine.random because sometimes it complains that it doesn't know the difference between UnityEngine.random and System.random. So this just clears up that ambiguity. And then we want to take this radius and choose a random position around the center using it. So return center. So this is the center vector plus, and then we're going to rotate the forward vector around the y-axis and multiply it by the radius so that we get our value that we want here. So quaternion dot Euler, and then we want to rotate it 0 degrees around the x-axis and then a random angle around the y-axis. So again, that's UnityEngine.random.range around min angle and, or between min angle and max angle, and then 0 degrees around the z-axis. And this, I'm not doing any special checks here. You do need to make sure that your minimum angle is less than your maximum angle. I'm not sure what will happen if you do it somewhere in there. It should be okay, but let's just say I haven't tested that. So we'll multiply this by vector 3.forward, and then we'll multiply it by the radius. So this should choose our random position for us, and we can use this not only in this class, but outside of it because it's a static method. Now let's move on to our private methods here. This one is going to remove all fish. So it's a pretty straightforward idea. We're going to, first of all, do if fish list does not equal null. If the fish list was never created in the first place, we don't need to remove anything. So once we've confirmed that, we'll say for int I equals 0, I is less than fish list dot count, I plus plus, so a basic for loop. And I want to clarify, the reason we're not doing a for each loop here is because if you try to modify the contents of a list while you're in a for each loop, it's going to complain. It won't let you do that. So that's why we're doing a for loop instead. We'll say if fish list at that index does not equal null, then we will destroy fish list at index I. Okay, so that's pretty straightforward. And then after this, once we've done our clearing, then we want to set fish list equal to a new list of game objects. So that's it for remove all fish. Now we need to move on to placing the penguin. So when we place the penguin, we want to choose a random position. And in order to illustrate what that looks like, I've created this diagram. It's a top-down view of the area. And basically we have this sort of dividing line down the center, and we have a snowy area, snowy icy area up here where the baby is going to spawn, and then we have a water area where the fish are going to spawn. So what I've indicated here is this blue radius here is where we're going to spawn the penguin. So it can spawn anywhere in here, and it can have any random rotation. So coming back to this function, we're going to say PenguinAgent.transform.position equals choose random position. And then we're going to pass in as the center transform.position. Then for our minimum angle and maximum angle, we're just going to say 0f and 360f. So anywhere in the angle. And then between 0f and 9f. So 9 is that radius that I just showed you. Then in addition to this, we're going to do a little kind of trick here. We're going to do plus vector 3.up times 0.5f. And all that's going to do is make sure it doesn't drop it, or it doesn't try to place it right at y equals 0. It's going to lift it up a little bit and let it fall naturally. And that just prevents it from spawning inside the environment and causing weird physics issues. Then we want to set PenguinAgent.transform.rotation. And we're basically just going to pick a random rotation here. So equals quaternion.Euler, and we'll do 0 around x. We'll do UnityEngine.random.range around y, so 0f and 360f, and then 0f around the z. And that should be the rotation. Now we need to place the baby. And so back to our diagram, we have this baby spawn area that we want to create here, this green area. This will make sure that it's not too close to the water and it doesn't show up in the water. So it'll be between these two radii and then these two angles. Now in our case, the angles are going to be -45 and 45 because this is 0 degrees right here. So we can delete this. And then we want to do something very similar to what we're doing above. So I'm going to take a little shortcut and I'm going to copy this and paste it. So the first thing I'm going to do, if you hold down, if you're in Visual Studio, if you hold down Alt and then you click and drag, you can actually delete that. So I just hit backspace and then you can type in baby instead, and then it edits both lines, which is pretty helpful. So now we want to use transform.position still, so that's the transform of the area. And we want the angles, the min angle to be -45f, and then the max angle to be 45f. And then we want this to be between 4f and 9f, so between 4 meters and 9 meters from the center. And we want to do the same thing here. And in this case, we're not going to do a random angle here. We're just going to do 180f, which means it's going to point toward the water. No matter what, it's just going to face the water. Now, we need to add our spawn fish method here. So instead of int v, we're just going to say int count. And then we're going to create a for loop that goes through. So for int I equals 0, I is less than count, I plus plus. And then inside the for loop, we're going to create a new game object called fish object. And that's going to be equal to instantiate game object. And the game object will be fish prefab.gameObject. Then we want to set the position and rotation. So we're going to say fish object dot transform dot position equals, and then we want to choose a random position. And so for the fish, we actually want to keep those in the water. So we're going to do an angle sort of like this. So if this is 0, then this is -90 or 270 degrees, and this is about 90 degrees. So we want to go a little bit beyond 90 degrees and a little bit less than 270 here. So we're going to do a choose random position, and I'm going to just copy this again just to keep it short. So we're going to choose random position. We're going to use the transform.position. We're going to set this to 100 degrees, so just past 90 degrees, and then we're going to go up to 260 degrees. So that'll sort of loop around the bottom half of that circle. And then we want our minimum radius to be 2 meters from the center, and then our maximum radius to be 13. And just to show you that again, the water can go quite a bit further because there aren't these sort of ice rocks, ice chunk things here that are blocking the spawn area. Now for the rotation, we're actually going to do the exact same thing as here. So I'm just going to copy all the way to here. I'm going to type fish object, and then I'm going to paste that in. So it's going to be a fish object.transform.rotation equals some random rotation. Now, ideally, these fish aren't just floating around without an area attached to them, or rather parented to an area. So we're going to say fish object.transform.parent equals transform. So that's just going to parent them to this area so that they are sort of self-contained. Now we're going to add this to the fish list. So fishlist.add fish object, and then finally fish object dot get component of fish. And we're going to call dot fish speed on this and set it equal to fish speed. Now this doesn't exist yet, so it's not going to be happy about that, but we will add that in pretty soon. So the last thing we need to add in this file is something in the update method. So add private void update. And then inside of here, type cumulative reward text dot text. So we're setting the text that's going to display our cumulative reward equal to PenguinAgent dot get cumulative reward dot toString. Okay, so here's another thing that doesn't exist yet, so make sure you spell it right, get cumulative reward. Same with this, make sure you spell it right, fish speed, because we're going to be implementing those scripts next, and these things will need to match. So you can save this file, we're all set with it, and ready to move on to the next one. All right, next we're going to open up the PenguinAcademy and work within that. And obviously if you see this error, it says that it doesn't contain a definition for fish speed. That makes sense. We haven't yet implemented it yet, so you can ignore that for now. So just open up PenguinAcademy, and this one's a pretty short one. So we'll add using ML agents to the top, and then we want to inherit from Academy. And then we can safely remove these functions. We're going to add a private variable called PenguinAreas, but it's a PenguinArea array called PenguinAreas. And then we need to override the Academy reset function. Now here's a little tip. If you type in OV, it's going to suggest override. You can hit enter, space, and then we want to override the Academy reset. We can remove this, we don't need it. And what we're going to do is get the PenguinAreas first, and we'll say if PenguinAreas equals null, then we're going to do PenguinAreas equals find objects of type PenguinArea. Okay, so that's going to populate this list, and then we're going to set up areas. And we'll say for each PenguinArea in PenguinAreas. Sorry if that's confusing. We're going to say PenguinArea.fishSpeed equals reset parameters, and these parameters we'll be setting separately. But essentially, we're going to set these parameters so that they can change over time. As the penguin gets better and better at feeding the baby, we're going to increase the difficulty. So at each step, it's going to recheck these reset parameters and see what their values are. So for the first one, we want fish_speed. That's what we're going to call it in our parameters file. And then we want PenguinArea.feedRadius set equal to reset parameters, and we want feed radius. So essentially what we'll be doing is at each step, we're going to either shrink the feed radius. So basically we'll start with a pretty big radius. So if the penguin gets anywhere near the baby penguin, then we'll consider that good enough. It's going to feed that baby. If we increase the speed over time, then it's going to make the fish harder to catch. That's the sort of thing. So we will gradually decrease that radius and make it easier or harder to feed the baby. And then finally, we need to do PenguinArea.reset area. So this is what's going to happen every time we reset the Academy. And that's it for the Academy. All right, now let's code the PenguinAgent. So open that up, and the first thing we'll want to do, again, is add using ML agents, and we want to set this to inherit from agent. And we can remove these, and start by declaring a couple of public variables which we'll use for referencing things. So public game object, we'll call this one heart prefab. This is going to be a heart that will display above the baby once we've fed it. And then public game object regurgitated fish prefab. Okay, so if you haven't seen babies feeding each other yet, then you don't know. But basically, just like other birds in the wild, they catch food, they semi-digest it, and then they spit it up or they regurgitate it into their baby's mouth. So that's what this is. It's going to be a little prefab of some goop on the ground that's going to act as the regurgitated fish. Then we need a few private variables. Private PenguinArea, private animator, private ray perception 3D, ray perception, that's what we'll call that. And then private game object baby. And then I guess we need one more, private bool is full. And let's make sure we spell that right. So is full basically means if true, penguin has a full stomach. So he can only eat one fish at a time, and as soon as he eats a fish, we're going to set this value to true, meaning he's full. And as soon as he feeds the baby, then he will be not full. And then we have our first method that we're going to write here. This is a override, so we can type override again, hit space, and then the one we want to override is agent action, this first one. Now we can delete this default code here. And the first thing we're going to do here is convert actions to axis values. So what does this mean? The agent action is basically what gets called every time the agent makes a decision. So if it makes a decision, it's going to make some decision based on what its different actions are that we've told it about. In our case, the actions are going to be move forward or not, turn left, turn right, or not. So those are the only actions it can take. So we're going to take in those actions. They come in the form of an array of floats. And then we're going to convert those actions into values that can be used to control the character. So we'll say float forward equals vector action 0. And basically what this means is it's going to look at that first value in the vector action array and see if it's 0 or 1. We're using, what's the word? We're not using continuous, we're using discrete. We're using discrete time steps basically. And what we're going to do is if it's set to 0, it's going to be not moving. If it's set to 1, that means it should move. And because those values line up with basically how much forward we want to go, this works. Now, what I just said probably doesn't make a lot of sense until I compare it to this. Float left or right. Okay, so its options in this case are either going to be 0, 1, or 2. Those are the different options it can choose. And so we want to convert 0 to don't move, so that's the default, 1 to turn left, and 2 to turn right. And so we're going to, basically they're code numbers, they're not actually values. Like in continuous, you would pass in -1 to 1. It would be a range, and you would sort of determine how much to turn based on that. In this case, it's saying, I want my turn to be value 2, meaning I want to turn right. So we'll say if vector action 1 is 1f, then we're going to set left or right equal to -1f, meaning we're going to turn -1 times however much we turn. Else if vector action of 1 is 2, then we want left or right equal to 1f. So that should set up our movement. Then we want to set animator parameters. And so the animator is basically what's going to control this penguin. Rather than control it with physics, we're going to use something called root motion, which basically takes the animator's natural forward movement and moves the character that amount. And so in order to control that, in order to say how much to move forward, we're going to use a blend tree. And in order to control the blend tree, basically when we blend between not moving and going forward or turning, then we need to give it some parameters to tell it what to do. So we're going to say set float, and we want our vertical parameter set to the forward value. So that's going to be somewhere between 0 and 1. And then animator dot set float horizontal, and that's going to be left or right. And this will make more sense as we create our penguin prefab. And finally, in agent action, we're going to add a tiny negative reward every step. And what this does is it sort of encourages the agent not to just sit there and do nothing. It encourages it, it learns that if it does nothing, it gets negative points. If it does something, then it's going to get positive points. So we'll do add reward -1f divided by agent parameters dot max step. So basically after the max step number of steps have occurred, then this will sum up to -1. In our case, this is only somewhat relevant. It's pretty much going to add -1 every single time. In some cases, if you were doing this and you exited early, like you fed the baby and you're like, cool, we're done, then you would get less negative reward in that case. So this is actually, now that I'm thinking about it, a little bit unnecessary, but it's kind of a practice that I've seen in a lot of the examples, so we're just going to keep it. Then we need to do public override void agent reset. And inside agent reset, we need to do a couple things. One, we have to set is full equal to false. So we don't want him starting the next round with a full belly, because that's going to be messing with the training. And then finally, we want PenguinArea dot reset area. Next, we want to do observation collection. So this is basically how the agent perceives its environment, how it observes the environment. Public override, and then we want the collect observations one. So we can remove this. And we're going to have a couple observations. So the first one is going to be, has the penguin eaten? And that's going to be add vector obs. So this just adds a new observation. Every time this collect observations is called automatically for us, we're going to give it some information, basically. And so this first one we're going to pass in an is full. So there are actually quite a few different versions of this. You can pass in a Boolean, you can pass in a float, you can pass in an int, a quaternion, a vector2, a vector3, an enumerable float. So that's like a list of floats, basically. Or an int observation in a range. I'm not entirely sure what that one's even for. But these are all the different things that you can pass in that will be consumed by the agent each step. So now we're also going to give it the distance to the baby. And we'll say add vector obs. And we're going to pass in the baby.transform.position minus the transform.position. So this is basically the relative vector from this agent to the baby. Let me make sure I spell that right. And then we'll just normalize that. Or rather, I did this wrong. Let's go ahead and normalize this. This is not the distance to the baby. This is actually the direction to baby. I got a little mixed up with my notes. So now the one that we intended to do here was actually the add vector obs vector3 dot distance between baby dot transform dot position and transform dot position. Okay. So these are the 3 observations we have so far. We're going to give it another one. Direction penguin is facing. And we'll do that with add vector obs transform dot forward. We could do this with rotation, so like a quaternion, or we could do it like a rotation angle or something like that, but we're just going to do it this way because this worked for me. Now this one is a little bit more complicated to grasp. Basically, it's going to have a number of ray casts at different angles, and these rays will shoot out from the penguin and sort of cast out a sphere. So it's technically a sphere cast. And if that sphere hits anything, then it's going to give back information about that. So I've added this comment that's going to kind of hopefully break it down a bit. So it's called ray perception, and this is basically our sight. And let's give ourselves a little line here. You don't have to type all this, but I'm just going to do it because I think it's helpful. So the first parameter that we pass into this is ray distance. And this is how far to raycast. That's pretty straightforward. We don't want to raycast to infinity. That's unnecessary. We don't want it to reach outside of the environment, really. Then ray angles is a list of angles to raycast. And these angles are a little unintuitive, so I wanted to add this little note. So 0 is right, 90 is forward, and 180 is left. So normally 0 is forward, and 90 is right, and 270 or negative 90 is left. But the way that they calculate the different angles in this, they use like cosines and sines, and they just kind of do it in a weird way. So just know that, you know, you kind of want 90 to be forward, and then you can just do symmetry from there. Then detectable objects is a list of tags which correspond to object types agent can see. So we're going to give it a list of tags, and then it's going to look for those tags and only report back if it sees them. Then we have start. These are 2 that we're not actually going to use, but it's helpful to know what they are. Start offset is the starting height offset of ray from center of agent. So basically it's like, where do you want this ray to start? Do you want it to start right at the center of the penguin, or do you want it to start like maybe 6 feet up or 6 meters up or whatever, 2 meters up, and then look down? Or maybe you want it to be only 1 meter off and then look out. And you can also set the end offset. And that's basically the same exact phrase here. So I'm just going to copy it. And it's the ending offset. So you can just kind of specify what your offset is. And I don't think it's necessarily only height. I copied this from their documentation. I think it's any offset. So we might want to start this from, for example, the penguin's eyes instead of from the center of its body. But we're just going to leave it as is. Okay, so now that I've explained how this kind of works, let's just implement it. Float ray distance equals 20f. So we're only going to look out 20 meters. Float ray, and this is an array of floats, ray angles equals, and then the angles that we're going to look at are 30, 60, 90, so this is our center line, 90, and then 120 and 150. So basically 5 different angles, 30-degree increments. Then we want an array of strings, and this will be called detectable objects. And the objects that we want to detect, the tags of them are baby, fish, and wall. And that's just what I'm going to use as sort of a generic catch-all for the colliders in our that are part of the area. So the edges of the space, the ground, the rocks, they're all going to be just wall in this case. not much need to give it a lot more detail. And then we want to do another add vector obs. And this time we're going to pass in ray perception dot perceive, ray distance, ray angles, detectable objects, 0f, 0f. So these two 0f's, actually now that I'm pointing it out, I'm realizing the start offset and end offsets do need to be heights. They're not, I thought they were vector 3's, but they're actually not. So they will need to be floats. That is indeed the height offset ray from the center of the agent. Okay, so that's going to wrap it up for these observations. Next, we need to add a start function, private void start. And we need to get our PenguinArea and set it equal to get component in parent. And we're going to find the PenguinArea component. So this is just whatever area the Penguin agent is in is what we're getting here. Then we want to set baby equal to the PenguinArea dot penguin baby. Animator equals get component animator. So we'll make sure that there's an animator on this. And ray perception equals get component, and we want our ray perception 3D. Now we want to do a fixed update, so private void fixed update. And inside here, we want to basically check, is the penguin in range of the baby? And then we're going to regurgitate the fish. Okay, so if vector 3 dot distance transform dot position baby dot transform dot position is less than PenguinArea dot feed radius. So basically, if it's within range of our acceptable feeding radius, then we're going to say close enough, feed the baby. And really, it's try to feed the baby, because we're going to call this regurgitate fish method, regurgitate fish. And this method, which does not yet exist, but we'll get to it in a moment, this is going to do that check and make sure that we're full before we regurgitate the fish. It's not going to allow us to do it otherwise. So let's right click and generate that method while we're here. Might as well. Now before we implement that, we're going to do a couple others. So this one is going to be private void on collision enter. Now, mostly what we want to do here is just compare against the fish, but we're also going to do a check to see if we collided with the baby. In the case that we set our feed radius all the way down to 0, we still want to make sure that we reward running into the baby and feeding it. So we're going to say if collision dot transform dot compare tag, and we want to compare it to fish. Then we want to call a new function that we'll make called eat fish, and we'll pass in the collision game object. Collision.game object. So eat fish doesn't exist yet. Let's just create it really quick. Okay, now it does. And we'll call this instead fish object. Now we will come down here and we want to do an else if, and we'll check collision.transform.compare tag, and we'll compare this to baby. And if it is the baby, we will regurgitate the fish. And this is another try to feed the baby instance here. because it's not necessarily going to succeed if it doesn't have a full stomach. So now we're going to implement eatFish. So we changed this from GameObject just because we don't want any ambiguity with the GameObject that already exists on this class. We'll delete this, and we're going to say if is full, return, because you can't really eat another fish while you're full. Okay, that's our restriction here. If you get past that, we're going to say is full equals true, not equals equals, just equals true. So we'll set it, and then we'll say PenguinArea dot remove specific fish object, and add reward of 1. So what we're doing is we're saying, all right, I'm full now. I'm going to remove that fish from the area, and then I get a reward every time I eat a fish. Now regurgitate fish, this is our last function in this file. So we're going to do a check at the top that says if not is full. So if it's not full, then we're going to return, because we don't want to regurgitate nothing. So we'll say nothing to regurgitate, and then we'll set is full equal to false if we make it past that return. We will spawn regurgitated fish. I apologize for picking such a difficult to type word. I apologize mostly to myself because I have to type it and not mess up every time. Okay, so we're going to create a game object called regurgitated fish. We'll set that equal to instantiate game object, and that's going to be the regurgitated fish prefab. Then we're going to set the parent, so regurgitated fish dot transform dot parent equals transform dot parent. So we're just going to parent it basically to whatever the agent is parented to, which is going to be the area. And then we will say regurgitated fish dot transform dot position equals baby dot transform dot position. So this is just going to set the regurgitated fish to be at the foot of the baby. Not exactly how it's done in the wild, but close enough. And then we're going to destroy the regurgitated fish that we just created after 4 seconds. So that's what this 4F means. Now we also want to spawn a heart. And this is going to show how much love the baby has for its parent, who is kindly feeding it fish. Game object heart equals instantiate game object heart prefab, and we'll say heart.transform.parent equals transform.parent, and same idea, we're going to do heart.transform.position equals baby.transform.position plus vector3.up. So we want this about 1 meter up from the base of the penguin, of the baby penguin. We'll destroy the heart after 4 seconds as well. And then we'll add a reward for feeding the baby of 1F. Okay, so that wraps things up for the PenguinAgent. All right, now fish is our last script, and I just want to commend you if you've made it this far, because if it's as brutal for you to follow along as it is for me to record this, then it's pretty tough. So way to go. We've made it this far. Let's keep going. So in fish.cs, we don't even need to import ML agents because we're not using it. We're going to keep it as a mono behavior. And we're going to delete this, and we're going to say public float fish speed, and then we're going to say private float randomized speed equals 0f. So just to point out what the difference between these two. So fish speed is going to be set by the parameters. Okay, so that's why we set in the PenguinArea toward the bottom, we set this fish speed. Now it's not complaining about this, or this actually. We're setting this value here, and this value is going to be sort of the master fish speed, if you will. So let's say we set this to 2, and 2 would be a pretty fast fish in this case, but the randomized speed is just going to make sure that it's not always moving at a constant speed. Sometimes it's going to be a little slower, sometimes it's going to be a little faster. We're just going to modify this each time, but keep that fish speed set to what it was originally. We're going to need another private float called next action time, and we'll set that to -1f. And basically this is, hey, when do you want to take the next action? Because we're going to send this fish on its way to a new position, and then after a certain amount of time, we're going to say, okay, pick a new spot, head toward that. So this time is going to be based on the number of seconds, seconds, I guess, since the start of the game. And then private vector 3 target position. So this is the target that we choose at any given point. So now we have a couple methods here. Private void fixed update. And inside fixed update, we're just going to check if fish speed is greater than 0, then we're going to call a method called swim. No point in doing all this work if the fish speed is 0, so that's why we do that check. And then we're going to right click, quick actions, generate method fish.swim. All right. Now, we first need to do a check. If time.fixedTime is greater than or equal to next action time, then we want to do some stuff. Now I want to point out the reason why we're doing fixed update instead of update is that the update method happens every time a frame is rendered. So depending on whether you're rendering at 30 frames a second or 60 frames a second, somewhere in between, it's going to do an update. For us, because we're working with physics, and every time we move these fish a little bit, it needs to update properly with physics, we're doing fixed update. Another benefit is that we're able to increase the time scale, which is something that MLAgents does a lot. It actually will simulate going about 100 times faster than real time so that it can train 100 times faster. And so in order to make sure that our fish don't just fly out of the environment or whatever, this kind of needs to happen inside of fixed update. And every time we use time, we have to use fixed time. And fixed time you can see actually in Unity. If you go to your project settings, which you can, I think, get to from project settings, yeah, right here, and you go to time, then you'll see what the fixed time step is. And that way, this is constant. It's always going to happen every 0.2 seconds. Okay, so in here, we're going to randomize the speed, and we're going to set randomized speed equal to fish speed times unityengine.random.range, and it'll be between 0.5f and 1.5f. So not too random, just a little bit of variation there. Then we're going to pick a random target. So this is where we're going to bring in that method from the PenguinArea. We're going to choose a random position. So we're going to say target position equals PenguinArea dot choose random position. And then we want to use the parent transform. So transform dot parent dot position. So since we set the parent of the fish to be the area, it's going to choose a position in the area. And the minimum angle will be 100f. The max will be 260f. The min radius will be 2f. And the max radius will be 13f. If these numbers sound a little familiar, it's because they're exactly the same as what we used here in this spawn fish method in the PenguinArea. We don't need to do the vector up one because the target they're going for is actually on the plane of y equals 0. So on the flat plane. Going back to fish. we want to rotate toward the target. And we want to say transform dot rotation equals quaternion dot look rotation target position minus transform dot position vector 3 dot up. So this is creating a look rotation in the direction of the target, basically, from the current position. And then we want to calculate the time to get there. So this is basically how much time will it take at our current speed to get to this new location. So we'll say float time to get there equals vector 3 dot distance transform dot position target position divided by randomized speed. So we're calculating the time to get there. Don't you love variable names like this? I really prefer doing variable names that are super descriptive as opposed to like float t, because when I come back to them, or if I'm just trying to read the code out loud, it just makes sense. So float time to get there is the distance between this position, divided by the randomized speed. It just makes sense. All right, I'm done patting myself on the back. Let's keep going. Next, action time equals time.fixedTime plus time to get there. So basically we get the current fixed time, we add how much time it's going to take us to get there, and that's the next time we're going to take an action. All right, and now if this is not the case, so if it's not time to take another action basically, then we're going to move the fish. So we're going to make sure that the fish does not swim past the target. So this, I thought when I originally implemented it, was going to be super easy, but it turns out if you speed things up dramatically, all bets are off. And I was having cases where the fish would just either jitter in place or sometimes would just rocket off and would not end up getting stopped on time. They would go way outside the environment. So we need to do some additional testing to make sure we don't blast past our target position. So we'll say vector 3 move vector. So this is how much we're going to move, or how much we're intending to move. And that's equal to the randomized speed times transform dot forward. So this is the forward vector of the fish times how much speed times time dot fixed delta time. So that's how much happens between each fixed update. And then we want to say if the move vector dot magnitude is less than or equal to vector 3 dot distance between transform dot position and target position. So this is just checking, is the length of the move vector, so the amount that we would move, less than or equal to the distance between those 2 points? If so, then it's okay. We can just do transform dot position plus equals move vector. So we'll just move as expected. But if not, we need to make sure that we don't move past it. So we'll just say transform dot position equals target position. And then we'll set the next action time equal to time.fixedTime. So basically, we're at our position. Well, let's move forward. It's time to take a new action, and then it'll trigger and then go into this loop on the next fixed update. So that's it for fish. And great news, everyone. That is it for all of the code. And we can move forward and start building out our scene. Okay, I don't know about you. I had to take a nice long break after that coding session, but I'm back. I'm fresh and ready to continue. So I'm going to hop back up to the assets directory and we're going to import some 3D meshes. So I'm going to create a new folder for those. I'll call that meshes. And then we'll open that up. And then the meshes that you want to use for this project, I'm going to provide in a link in the description. So we have a baby penguin, a fish, a heart, a penguin agent, a PenguinArea, and a regurgitated fish. So all the stuff that we've already used in our scripts. And then I'm going to take it and I'm going to drag it into my project, and that will import it. Now, each one of these is a little different. So if you go to the inspector view, you can view them. Some of these will have previews because they have animations on them. And those ones with animations on them, we need to do some special steps to make sure that they import properly. Most of these, the default settings are just fine. Let's start with the baby penguin. And what we need to do first is go into the Rig tab. And it's going to have root node set to none. We need to change that to the root node that's here. So this is the root bone. And then we're also going to optimize game objects. And then hit apply. So setting the root node is going to make it so that we can actually move this object based on its animations. And then optimize game objects will make it so that it doesn't create an empty game object for every single bone in the animation. There are some cases where you want to use that, but not here. So after you have that applied, when you go to animation, then it's going to have some new options that weren't there the first time around when you went to your animation thing. Now, for me right here, for some reason I have two of these. I think that was an export setting that I mixed up. So I'm going to fix that by the time that I export this. But the one you're going to want is this baby penguin, and then like this vertical line idle. And then I'm going to see if I can hide this a little bit. You want to check this box for loop time. This is and loop pose. So that what this is going to do is it's going to make it so that when the animation is going, when it hits the end of it, it's just going to loop and repeat it over and over again. And then we also want to add this root transform position Y. As of right now, this baby penguin doesn't actually move, but I want you to get in the habit of doing that because we're going to have to do it again for the penguin agent. So then we should be all set with this. We just hit apply and we're done importing with the import settings for baby penguin. Now we need to do this for PenguinAgent as well. So we're going to go into the Rig tab, change the root node to penguin root, and optimize game objects. Then click apply, go to animation, and then for each one of these four, we need to do that thing that we did for the baby penguin. So for forward, which I'll just show you, is this forward movement right here. We're going to loop time, loop pose, and root transform position Y. And we don't need to apply it every step. We'll do this for each one of these animations. So this is the idle animation. And I made these models and I didn't have any creative ideas for what to do on idle. So we just kind of nods his head. Then we have turn left. So I'm going to set loop time, loop pose, and root transform Y, and then turn right. So just to show you kind of what that looks like, and check these boxes. And now hit apply at the end, and this should be ready to use. So this forward, when it actually moves forward, it's going to move the object forward in the world, which is pretty cool. Now we're going to take each one of these and we're going to create prefabs for them. So the first one we're going to work on is the baby penguin. So I'm going to drag that into the scene. And then I'm going to rename it to baby penguin, like that. And I want to go up to assets, create a new folder called prefabs. And then I'm going to open that up and drag the baby penguin down in here. We want to choose original prefab. So this baby as is, it's just a transform and an animator. And the animator does not have a runtime animator controller set on it yet. So we need to do that. We need to set that up. So I'm going to hop up here. We're going to create a new folder called animations. And inside animations, we want to right click and we will create a animator controller. And I'll just call this baby animator controller. And I'm going to set this up. We have to double click it, and then your animator window will pop up somewhere. In the past, I've had it pop up down here. You can just click and drag the tab up to wherever you'd like it. Now, we need to add a new state here. We're going to right click, create state, empty. And then if you click on it, you can change the name. We'll change it to idle. And we're going to change this right here, this animation, to baby penguin idle. And that should be it for this particular animation controller. So if we click back on this, we want to open up this baby penguin. So when it's in the scene, if you see it like this, you don't want to edit in the scene view because that won't commit the changes to your prefab. You want to click on this little arrow and that'll open up the prefab. So we want to drag this into our controller for this. And then we want to set a few other things. So we want to add a rigid body to this so that physics will work. So we'll say rigid body. Make sure you pick this one, not the 2D one. And we're going to also set some constraints on this. We don't want him to rotate at all. I'm going to make it so that he can't rotate in any direction. But he can kind of be knocked around a bit by the penguin. I've decided that that adds a little bit of fun to it. Then we add a capsule collider. And we want to make this so that it kind of fits around him, not the way it is currently. So in order to do that, I'm going to switch from perspective into isometric. So you can click on this to switch into isometric view. And then I'm going to view him from the front by clicking this Z. And then I'm going to edit this collider. Oh shoot, not like that. I'm going to Control Z to undo that. I'm going to change the radius instead to fix this. So I'm going to click and drag this to set the radius to about 0.14. And then I'm going to use the edit collider thing to move this point up to about there. Okay, so that creates a collider so that when the penguin runs into it, we can recognize that that has happened, and also he'll react to some physics. And then the last thing we want to do is we want to set the tag on this to baby. So if you go up to tag, there's no baby tag in here. We're going to add a new tag, and we're going to create one called baby. And then we will save that. And then remember, we're also going to use fish and wall. Wall already exists here. They've used that in another example. But I'm just going to add that fish one now too, since it's convenient. So we have baby and fish added. We have to go back to this, click on this inside here, and then we want to change this to baby. Okay, so that should do it for our baby penguin. So now that we have this prefab saved, we can delete him from the scene. Now we're going to go up to our meshes again, and we're going to do the heart next. The heart is basically, we don't have to do any work for it really. I'm just going to call it heart with a capital letter, and then I'm going to drag it down into our prefabs folder. Create an original prefab, and then I can go ahead and delete that. Then we want to do our fish. So we'll go into our meshes, we'll pull a fish into the scene. I did not go into much detail on the fish here when I modeled that, so it looks a little cartoonish, but that's fine. And I'm going to rename this to fish, and I'm going to create a prefab for it. So I'll drag this down, create an original prefab, and then I want to open that up. So there's two ways to do this. You can click on here, or you can click on this. You can double click it. I guess that's three ways. Or you can open prefab. Either way, we need to be in this prefab editor thing. And then we're going to set the tag here to fish. And we need to apply a rigid body and a capsule collider to it. So let's do that. So this was already selected. It doesn't really matter what order you put these in, as long as it looks like the right idea here. So in this case, I'm going to switch into isometric view, and I want to view it from the side here. I'm going to set the direction to be the z-axis so that it expands along this direction. And I'm going to change the radius down. If you click and drag, you can kind of change the radius. And then I'm going to increase the height. And so these values 0.14 and 0.66 seem to work pretty well for that capsule collider. I'll add a rigid body so that collisions work. And we want to lock the X and the Z rotation. So we don't want it to rotate around the Z-axis, meaning that it would just roll, or the X-axis, which means it would like flip over. Only the Y-axis rotation really makes sense for us. And then we need to add the fish script to this. So if you type in fish, then our new script should show up, and it'll have that default speed of fish speed 0. Okay, so now we can delete this fish from the scene, and we can create another really simple one, and that's going to be the regurgitated fish. And that's just this blob that's going to show up on the floor. So we will rename this just to have it look a little different. Sorry for my mouse. Regurgitated fish. And this, we don't need any colliders or anything like that. It's purely for display. So I'll go into Prefabs, and then I'll drag this down in, create an original prefab, and then I'll delete this from the scene. And then our last one that we need to do at this moment is create a Penguin player. So I'm going to take the PenguinAgent, drag him into the scene. And he's quite a bit bigger than the baby and the fish. And I'm going to rename it. This one's going to be called Penguin Player, which is going to be distinguished from Penguin Learning. So this player is going to be something that we can control, actually. We're going to use that to test out our area and make sure everything's working properly. So open up your prefabs directory, drag this in, original prefab, open the prefab, and then we can start doing a few things. This one needs quite a bit more attention than the other ones. So the first thing I'm going to do actually is I'm going to attach a PenguinAgent script to it. And then I'm going to hook in the heart prefab and the regurgitated fish prefab. So let's drag those in. Heart, regurgitated fish. Okay. And then we have need of a rigid body, so let's add that. And we're going to, again, freeze the rotation in the X and the Z. Whoops, not the Y. We want them to be able to rotate around the Y-axis, this green one, but not the other two. And then we need a capsule collider. Okay, so we want to edit this again. And I'm going to switch into isometric and then view it from the side by clicking that red X-axis. I want this to expand along the Z-axis. I want to kind of change this radius down a bit. And probably just edit collider for this one. So I'm going to drag this up, drag this one up, kind of go like this. That's about right. Doesn't need to be perfect. And then we're done with that. We need to create an animator controller for this. So let's do that while we're working on the penguin. So we're going to go to animations. We're going to create a new animator controller, and we'll call this one Penguin Animator Controller. And this one's a little more complicated. So we're going to open this up, and this time we're going to right click and choose Create State from New Blend Tree. So the blend tree here is going to allow us to blend between different animations that we have. So the first thing I'm going to do is I'm going to create a couple of parameters. One is going to be called horizontal. And this spelling is super important. Don't mix this up because this is going to be accessed. I'll create another one really quick and then I'll show you where. Vertical. These two values are going to be accessed from code via script. So the PenguinAgent, when we set these values, animator.setFloat, vertical and horizontal, these need to match because this is where it's setting them here. So if you click on the blend tree, you will have actually you need to double click on the blend tree to go in, and then you click on blend tree. You have the option to change your blend type, and we want to change it to 2D freeform Cartesian. The first parameter should be horizontal, and the second parameter should be vertical. And we're going to create our first motion field, and we can actually create 4 of these. And you'll see as you do this, it adds a few points to our graph. So this graph is going to help us visualize basically the interpolation between the different states that we're in. So the first one we will create is the penguin idle state. And you can also see down here that it's on the PenguinAgent script. So don't confuse that with this idle right now, which I'm going to try and remove before I upload these meshes. So penguin idle, and that's going to be at position X and Y, meaning when the vertical axis is 0 and the horizontal axis is 0, then he's not going to move. He's just going to do his idle animation. Then we're going to set the second one to penguin forward. And this one's going to happen when the position in the X is 0 and the position in the Y is 1. Then we're going to do a turn left and a turn right. Okay, so turn left makes sense. The position in X is -1. For this one, it should be +1 and then 0. And so now you can see that there's these 4 points on this diamond. If you press play, it's going to start, and wherever this red thing is, it's going to modify the position. So in this case, the X position is going to go to negative, and he starts turning. In this position, I'm clicking and dragging, and he's turning right because the X position is positive. Now, if I start moving forward, then my vertical position, the Y position, is going up, and I can kind of experiment by going between these. And you can kind of drive your penguin around just by doing it this way. We don't have a way to go backward because I think penguins generally will slide forward, not backward. Okay, so that's our blend tree. And if we back out to the scene view, then we click on our penguin player. We can set the penguin animator controller to be in the animator here. And then the important thing that we need to do here is set the update mode. This one is critical. If you don't do this, then you're going to have issues when it speeds up the game. I found this was happening to me. I have to animate physics because we're using root motion to move this penguin forward. If you don't animate physics, I looked in the documentation, basically it updates the position of this thing every fixed update rather than every update, which is how it does it for other animations. For the baby penguin, it's okay if we do it on the normal mode because we're not moving him around. But for this one, definitely super important to update this one. Then we want to set a few things here. So max step we're going to set to 5,000. So that means after 5,000 steps he's going to reset. And then we're going to set the decision interval to 5, meaning that he's going to make a decision and then for the next 5 steps he's just going to take that action. Because there are so many steps per second, it just seems to be helpful not to have him make a decision every like nanosecond basically. That's probably an exaggeration, but you get the point. So now the last thing we need to add to this actually is a ray perception. And that's a ray perception 3D. We don't have to set anything on this. We'll set this in code. The last thing we need to do for our PenguinAgent is add a brain. Without a brain, it's not going to do anything. So let's go up to our assets directory, right click, create a new folder, and we'll call this brains. And inside of brains, we're going to create a new MLAgents player brain. And so there's a few things we need to change in here. Technically, we need to change this vector observation, but rather than do the math and figure out exactly how many observations this thing is going to use, we're going to kind of use a lazy version where when we hit play, it's going to complain and say that it doesn't expect the number of observations that we're giving it, and we'll just figure out what that is from that error message. Then we want to set our vector action space type to discrete, so you don't actually need to change anything. That's just what it is, set by default, as opposed to continuous. And then we want to set our branches size to 2. Okay, so when we take actions, we basically have a few different things. So the first branch is going to have 2 different options. Either I'm not moving forward or I am moving forward. And the second branch is going to have 3 options. Either I'm moving left, I'm stationary, or I'm moving right. So if we go in here, we can change our branch descriptions to say move forward and turn left or right. Now the player brain is kind of special as opposed to the learning brain. I guess all the brains are special. They all have different things. So this one has discrete player actions. And so we have 3 discrete player actions. And what these are going to do is allow us to control this penguin. So the first thing, we're going to use the W, A, and D keys to control movement of the penguin on the keyboard. So this first one, we're going to find the W key here. I think I can just type W, and yeah, it chose that. Branch index is 0, and the value is 1. So when I hit W, then a value of 1 is going to be passed in from this brain into the Penguin agent and into this agent action vector. So this first thing right here, it's going to get a forward value of 1. And if I don't do it, the default is going to be 0. Now, the next element that we want to do is going to be A. So I see it right here. And I'm going to set the branch to 1 and the value to 1. And the reason being, the default is always going to be 0. So I want 0 to always equal not moving. And then I want the second option, 1, to be turning left. And then this third one, we're going to set it to the D key. And we want it to be 1, 2. Okay, so coming back into here, in this case, we have our left or right. So by default, it's going to be 0. And then we say, if this vector action is equal to 1, then we're going to set the left or right turn amount to -1. And if it's equal to 2, then we're going to set the left or right equal to 1. All right, so that should be good for our player brain. We need to click on Penguin Player, and then we need to, I want to rename this to Penguin Player. And then I want to click on this, and I want to move it into the Penguin Agent script. So that should be good. We'll hop back out to our scene, and we can delete this Penguin Player from the scene. Now let's set up our player area. So we're going to have 2 different versions of the area. One is going to have a player in it, being us, and the other one's going to have a learning penguin in it that's set up to learn. You don't have to do it this way, but this is a way that makes it easy to switch between experimentation mode and regular learning mode. So we're going to go into our meshes folder. We're going to drag this penguin area up into the scene. And if we scroll out, you can kind of see this scene here. So the first thing that I'm going to do is I'm going to rename this and make it a prefab. So if we open up the prefabs directory, and then we can just say Penguin Player Area. And I'm going to drag this down into the prefabs, create an original prefab for it. And then I want to open this prefab. And then we need to set up the mesh colliders. So when I modeled this, I created some mesh colliders. And one of them is this wall that goes around the entire thing. And if you look at it from different angles, you can kind of see that it's facing inward. So this is basically an inverted cylinder with a little slope in the middle for this shoreline that it'll be distinguishable in a minute. But you can also see that there's a top on it, so they can't fly out and go up to the top of the cylinder somehow. So we need to set this inverted cylinder collider. We want to add a component, and we're going to type in mesh collider. This is the one we want. And as long as you leave on this mesh first, you don't remove these first, then this will autofill with this mesh. If not, you can try and find it in here if for some reason it didn't autofill. But now that we have this collider on here, we don't need to render this. So we're going to remove these two components right here and leave just the mesh collider on there. So now you can see that we have this collider object on there, and as soon as you click away from it, it'll disappear, and it'll just prevent the penguins and the fish from getting themselves out of the environment. Now we also have these rocks. I'm going to so these, as you can see, I'm going to focus on them. These two don't really look like rocks at all. That's because they're colliders as well. So I'm going to add another mesh collider to this one, then remove these two components, and you can see that it has more detailed rocks underneath, but these larger sort of tents almost prevent the penguin from getting caught in these little cracks. So same idea here. We're going to add a mesh collider and remove these two. So now we've got our area and the colliders all set up. We need to do a few more things. So the mesh colliders, so I'm going to actually control select all of these, and I'm going to change the tag to wall. So that's going to allow the penguin to have some idea that it's about to run into a wall. And then we need to add a couple of materials. So I'm going to back out here. I'm going to create a new folder called materials. And inside materials, we're going to create two. I'm going to create material. I'm going to call this one snow, and the only thing I'm going to do is I'm going to reduce the smoothness down to 0 for this, and then I'm going to create a new material. We're going to call this water, and water I'll lower the smoothness a bit. I'm not going to take it all the way down. I set it to about 0.15, and we're going to change the rendering mode from opaque to transparent. And we're going to change the albedo from white to something blue. You can kind of choose your preferred shade of blue here, and then just change this over here. And then we need to change the alpha down somewhere around maybe like 155. That should be pretty good. That should give us some visibility. And you can always come in and change this if yours didn't turn out quite right. So now what I'm going to do is I'm going to apply this snow to pretty much everything in the scene, and the water to the water. So this right here, this shape right here, the water, that's going to turn blue. And then the rest, even though it's the default white, I'm going to apply this white material to them. So not the colliders, they don't have anything to even put it on. But the snow is going to go on rocks 1 through 6. And then the iceberg as well. Okay, so now we've got our materials on there, and you can see that there's sort of this appearance of water, which is kind of a neat effect, without us having to do much actual work to accomplish it. Now we want to add a cumulative reward text. So basically I'm going to add a space over here where it's going to show text that shows how much reward the penguin has received each episode. So we're going to right click in here. We're going to create a 3D object, text mesh pro. It's going to ask us if we want to import the TMP essentials. The answer is yes, so click this button. And then when it's done, it's going to ask us if we want to import examples and extras, and the answer is no. Oh, it opened up Visual Studio on me. Okay, so we're not going to do that. We're just going to close this out. And so if you have any trouble, I've had cases before where it kind of messed up and it didn't show this sample text. It was just like a gigantic box in my scene that was empty. In that case, just delete it from your scene, this text, and then right click and go into create this Text Mesh Pro again. So we're going to rename this to cumulative reward text. And we need to change this to basically be more visible. So I'm going to change the, the sample text to 0.00. I'm going to change the font size to 20. I'm going to change the vertex color to black so that it's nice and visible. Then we're going to change the alignment to centered and middle. And then we just want to move this to a place that makes more sense. So you could have this on the floor, you could have it in the water, doesn't really matter. My choice is to move this over here and kind of move it up a bit. And then I'm going to rotate it something like that. Okay, so now you can see this reward text, and it's going to tell us what the current reward is once we hook that up. So we're going to also add a couple of our prefabs. So we're going to take the penguin player and drop him in, and the baby penguin and drop him in. So they're currently inside of each other. So I'm going to take this baby penguin and I'm going to move him over here somewhere. And then I'll leave the penguin player where he is. And then we just need to hook up the area script. So at this top level, click on the penguin player area. We want to find the PenguinArea script. And then we want to hook up these different things that we created. So we created this PenguinAgent, so the player will go in that slot. The baby penguin will go in here. The fish prefab will come from our prefabs folder. And then the cumulative reward text will go here. Okay, so now our area is properly set up. The one last thing I want to do, I'm going to back out to the scene, so you can either press this button or click scenes. And I'm going to make sure that this camera, which currently sees sort of straight on, you can see this camera preview, not as easy to see. I'm going to change this main camera to be sort of what my current view is. So I'm going to get a good angle on it. I'm going to make sure that I can see where this reward text is and that I can see pretty much the whole thing at once. And then I'm going to go make sure that this main camera is selected, go to game object, align with view. And now if I switch into game mode, I can actually see this whole area. So that'll be helpful for when we're controlling things. Now we're going to create an academy. So I'm going to right click. I'm going to create an empty. We're going to call it Academy. And it doesn't really matter where its position is, so I'll just leave it. And we're going to add a PenguinAcademy script to it. And we need to add our Penguin Learning Brain to the Broadcast Hub. So if we click on this, add new, then we can add a brain. I'm going to click this little circle and type in Penguin. And the only option we have right now in our brains is Penguin Player. And then I'm also going to, I want to point out something. So there are reset parameters here. I'm going to intentionally leave this part unset so that you can see what this error message looks like, because it seemed like a lot of people were hitting this problem. And in fact, I hit this problem a few times myself, and it's just good to have seen the error message before and know that this is what's causing the problem, because it's not the most intuitive error message. So I'm actually going to rename this not to just Academy, but I'm going to call this Player Academy. And then I'm going to create a prefab out of it and place it down here. Okay, so we should be ready to go. We're going to do a quick play test and see how this plays out. So let's save the scene, and we're going to hit the play button. Okay, so the first thing we see is red. So we're going to pause this, or hit play, not pause. And you see that like every single frame we were getting this key not found exception. So that's kind of alarming because it's not obvious what it is. But usually when you see something like this that's happening every single frame, you do want to go all the way up to the top and make sure that there isn't some other error that's causing this, because sometimes errors can cascade. This is indeed the first error. And so let's take a look. We have key not found exception. The given key was not present in the dictionary. And this is just some like more specifics. But then it's actually happened in our PenguinAcademy.academy reset. So on line 21. So where's that happening? We go into our code, Penguin Academy, line 21. We have this. It's trying to access this fish parameters fish speed, but we haven't told it what fish speed is. There's nowhere that it does that. When we're doing training, that's going to be passed in from externally. But when we're just doing play mode and we're just playing with this Penguin player brain, then we need to set those somewhere. So we'll go into our academy, we'll open up the prefab, and then we need to add a couple of parameters. Okay, so the two parameters we need to add are fish speed and fish radius. So these need to match. Let's make sure that we have exactly what we need. So fish underscore speed, all lowercase, and fish underscore radius, all lowercase. So we're going to add two reset parameters. Fish underscore speed and fish underscore radius. And the radius that we're going to start with is 1. So this is going to prevent that error from happening, hopefully. So I'll save my scene again and I'll hit play. Okay, so that error is still happening. So it looks like those didn't stick. Okay, I'm not sure why that was happening, but I found a way around it. So what we're going to do is right click. We're going to create a new empty. We're going to call it Player Academy. We're going to add a component of Penguin Academy, add brain, and we need to do our Penguin player. And we're going to add two reset parameters here. We're going to add a parameter called fish speed. So that's going to correspond to this value right here. So make sure that it's all lowercase underscore fish speed. This has to match. And then feed radius. So we'll add this one, feed radius. I'll set this to 1. And then I'm going to drag this Player Academy down here into the prefabs. And it seems that the prefab now has these saved in it. So we should have this ready to go. It should fix this error message, this key not found exception. So let's see what happens. Okay, so now we're getting a new error. All right, so we scroll up to the top and we see that the Unity agent's exception vector observation size mismatch between continuous agent Penguin player and brain Penguin player was expecting 1 but received 33. So all this means is that in our player brain, so if we hop back out and we go to brains and click on it, it's expecting a one vector observation because that's all we told it was going to exist. It's expecting, or it's receiving 33. So these 33 are coming in from our Penguin agent anytime we call collect observations. So the number of all these adds up to 33. You can try and work this out and figure out, okay, how many are there? Okay, so there's 1, it's a Boolean. Okay, so that's 1. Then this distance is 2. And then this direction is 3 of them. So we're up to 5, and then another 3. So we're up to 8 for this forward one. And then you can add on this whole number of vector observations. And so it's a little complicated, so I'm not going to explain exactly how it works this out. You can go in and look in this code if you're interested. But sometimes it's just easier just to see how many it actually wants. You're likely to hit this error if you're experimenting anyway, so I figured it was helpful to show it. So once we've changed that in the Penguin brain, we should be able to save the scene and press play. And now you can see that this is showing up. And we can move our penguin by doing the A and D keys. We can turn, and then we can do forward with the W key. Now I'm going to run into this fish and pick it up, and you can see that my score increased. This was intended to be a lot more truncated, so I'm going to have to look into that. And then if you try and pick up these other fish, it just kind of knocks them around. It doesn't pick them up because he's full. And then we're going to take it over here to this baby penguin and drop it off, and then we get a little heart. And we can pick up another fish. So this is how we kind of test and make sure that this is working properly so that we don't have errors that happen that end up causing problems when we're training. It's always good to do it with a penguin player first. Not always good to do it with a penguin player. If you don't have penguins in your scene, you probably won't have penguin players. In general, just do it with a player brain first, and then you can experiment with learning brains. Now, in order to fix that text that was not showing up correctly, that was showing up way too many decimal places, just come into the PenguinArea, scroll down to the bottom of the file, and where we're setting this cumulative reward text, you just want to add this string to the toString, this 0.00. That's going to make sure that it formats it correctly. And so now, when we hit play, you'll see that it doesn't have tons of precision. It's just going to update much more cleanly, and we'll be able to see things go. So I'll just show you really quick. I'll pick up this fish, and then it just stays with 2 decimal places like that. So now let's move on, and let's start setting up a learning space. Okay, we're going to create basically a duplicate of these 2 things in the scene. But before we do that, let's create a duplicate player. So I'm going to go into Prefabs, and I'm going to drag this penguin player into the scene, and he's going to be right on top of the other penguin. So you won't necessarily be able to see the difference. But we're going to open this. Well, first of all, let's rename this to Penguin Learning. And then we want to drag this down into Prefabs, and we're going to create an original prefab. So this is a completely new prefab. So if we change it, then we won't be changing the default penguin player that we changed it from. So we want to open this prefab. And then inside here, we need to hook this up to a new kind of brain. So we're going to go into our brains folder, right click, create ML Agents Learning Brain. We'll call this Penguin Learning. And make sure that yours is spelled this way because there are some things that are hooked up that we need to make sure are spelled exactly the same. So capitalize the P, capitalize the L, and spell it correctly. So once we're in here, rather than have to set up all these brain parameters again, there's this shortcut that's really cool. We can actually drag in Penguin Player, and then it copies all of these brain parameters automatically for us. So these would have been blank, and now it's all set up, so we don't have to do that, which is pretty cool. All right, so we need to go back to Penguin Learning, and we need to hook up this Penguin Learning brain into the brain slot. And then we can back out, and we can delete this from the scene. Now we need to duplicate the area and the academy. So what I'm going to do is I'm going to just create a duplicate here, and I'm going to remove this one, and I'm going to call this Penguin Learning Area. Okay, and then we're going to go into our prefabs folder, and we're going to drag this down so that we can create an original prefab out of it. So that anything we change in it now won't be messing up the other stuff. So we're going to go into the Penguin Learning Area, and we need to replace this penguin player with a Penguin Learning. So I'm going to delete this, and then I'm going to drag a Penguin Learning into the scene, and he should still be at 000. And we're going to make sure that on the area here, we hook up this Penguin Agent. So I'm going to put this Penguin Learning into here. So our learning area should be ready. So we can hide this Penguin player area now. And then we have the Player Academy that we also want to duplicate and rename. And I'm going to call this Learning Academy. And I'm going to create a prefab of it before I start messing with it. Create an original prefab. And I can actually disable this now. And I'm going to go into this to open the prefab. And then I don't want this to be Penguin Player. I want to remove that. And I want to add the Penguin Learning. All right. So let's back out and let's make sure that this is still, it's still set to Penguin Player. I don't know why this keeps messing up. Let's try changing it here. We're going to change this Penguin Learning Academy here to Penguin Learning. And then hopefully we can save this. It still says no overrides. That is super weird. Okay, well, let's see if we can go into our prefabs folder and delete this Learning Academy prefab that we created. So we'll delete that. And then this thing, hopefully, we can just drag down into prefabs. And then it saves it. Yeah, okay. So there's something weird happening with the Academy there. So maybe you'll hit it, maybe you won't. I'm not sure why I'm hitting it, but basically you need to make sure one way or another that your Learning Academy has this Penguin Learning Brain hooked up to it and that it has the reset parameters. Now there's one more thing on this Academy that's going to change depending on what we're doing. So by default, it's set to use the basically the Penguin Learning Brain, assuming that we have a trained neural network already. When we're wanting to train, we have to check this control checkbox. And also I want to point out a couple of things. Inside here, you have training configuration and inference configuration. So if we're training, it's currently set to a time scale of 100. If you find that your computer really can't handle going at a time scale of 100, you can lower that down, maybe to like 10 or something like that and see how it goes. But I'm going to do 100. I'll actually revert that. And then the inference configuration is what speed it runs when you're basically testing it out and seeing how well it works. So a time scale of 1 makes sense. In order to start training, we need to set a couple of configuration files external to Unity. Let me save my scene really quick. So if you open up your ML Agents directory, this is the one we downloaded at the beginning and where you pulled your assets from. We're going to hop back up to this parent directory here. Go into config. And the first thing we need to do is open this trainerconfig.yaml. So I'm going to drag it into Visual Studio so that it opens in the right place. And this is where we set the hyperparameters for our deep learning or our machine learning. And if you have experience with machine learning, then you have experience with hyperparameters. For those of you who don't, just know that these things do affect training quite a bit. And so if you don't know what you're doing, I wouldn't mess with them too much. I would just copy from one that already works. So every single brain that exists in the samples, the example projects in ML Agents is represented here. And they all have different things. So things like learning rate and batch size and num layers. These are all things that if you've done some machine learning before, these are going to sort of click and make some sense. We're going to add our own section here, of course. And we need to add it to the bottom. Well, it can go anywhere, but I think it makes sense to add it to the bottom. So we're not going to change every parameter. We are going to set it to these values, and I've already got them here. So I'm going to recommend that you just copy what I have here. So we're going to have something called Penguin Learning. And remember, this has to match exactly the name of your brain in the environment. So make sure you have your capitals right and your spelling correct. We're going to set use_curiosity to true. So curiosity is something that seems to really help make sure that the agent explores the entire area. So it tries things that it's never tried before just because it's curious, which is kind of a neat thing. The summary frequency, we're going to do it every 5,000 steps, and that's because we are only resetting our area or our agent every 5,000 steps. So to do a summary in between doesn't make a lot of sense. Then our time horizon, we're going to set to 128, our batch size to 128, our buffer size to 2048, hidden units to 256, and by default, the layers is 2. So we have 2 layers of 256 neurons. Beta 1.0 E-2, and then max steps 1.0 E6, which is 1 million. So we're going to do this for 1 million steps, which is about how long it took me to get to a really good place. And just to show you where I pulled some of these values from, I did do some tweaking. I actually copied these or I used as the basis the pyramids learning one, because this is kind of a similar project to what we're doing. And I highly recommend you check out that pyramids learning thing, because that kind of is a cool use of curiosity. So that's one. And then the next thing we need to do is set up our curricula. And I already have curricula in here. So you will need to create a new folder, and you'll call it Penguin. And we'll open up Penguin, and then you're going to need to create a new folder or a new text file called penguinlearning.json in this folder. And again, this needs to be an exact match to the name of the brain. So whatever you called it in this trainer config down at the bottom, same exact name needs to come in here. So I'm going to open this up as well, and I'll show you what I have in here. Rather than force you to watch me type this out, I'll just let you sort of pause and copy these values, but I'll explain what they are. So measure of reward, there's only like 2 options for measure, but what it is going to allow us to do is measure the average reward that these agents are getting every some number of steps, every some number of episodes. I think it's just probably every 5,000 steps that it's going to do this. And if the reward is higher than a threshold, then it'll jump to the next curriculum difficulty, basically. So in our case, we have several of these thresholds. So at first, it's going to get negative points, no question, because if the penguin takes no action, it's just going to get points taken away from it. So I set this threshold at negative 0.1, because every time a fish is collected, it's going to get a score of 1. So as long as we're getting over negative 0.1, that means that like 9 times out of 10, he's picking up a fish, which is what we want for this first round. That's really our only goal. I am going to add a feed radius of 6 meters, meaning that if it gets within 6 meters of the baby, then we'll feed it. And that's just kind of going to start training it like, hey, once you picked up a fish, you might want to head over to that baby thing. I'll explain some of these other ones in a sec, but let's talk about min lesson length. All this is it's going to take the average of the previous 80 episodes, and if that is higher than the threshold, then we're going to bump up to the next one. So that's really how it works. Signal smoothing true. This is just always on in the examples I've seen, so I'm keeping it on. I could hypothesize about what it means, but you can read the docs for that. All of these variables are documented quite well in the Git repo. And then finally, we have our parameters. So we have fish speed and feed radius. So fish speed is pretty straightforward. It's how fast we're going to make our fish be. And for the first several of these, we're not going to let the fish move at all. I don't want to introduce that difficulty. But then at the end, we're going to speed them up a little bit and have the penguin actually have to chase after them and catch them. Then we have feed radius. So this is how close we need to be to the baby penguin in order to feed it. And so at first we start out at 6 meters, and then we're going to knock it down to 5 meters. And once we have it set to 5 meters, the threshold to get to the next one actually becomes positive. So it's 0.7. And because we're always going to knock off negative 1 point just for living, life is tough for a penguin. Then he's going to get a point for picking up a fish. So that'll negate to a default reward of 0, basically. Every time he picks up a fish, he's going to get total points of 0. In order to get beyond that, he's going to have to learn that he has to take that fish and take it to his baby. And so that radius of 5, basically, if he can get within 5 of the baby, then we're going to give him a +1. And so as long as he feeds the baby at least once, he's going to get 1. And the threshold will be, it'll be matched. This 0.7 just means, like, on average, 7 times out of 10, is he feeding the baby? And so that, when we've passed that threshold, will bump up. And so this one's going to force him to feed the baby twice. And we're going to reduce the feed radius to 4. And I found that this really helps because when you have your agent moving around the space, if there aren't a lot of things that it can run into, like the fish, we have 4 of them. So the odds of it running into a fish are actually pretty high. So it'll learn that picking up a fish is a good thing just purely randomly by running into these fish in the environment. But the then next step of taking that fish back to the baby is less likely to happen randomly. And I can say that from a lot of experience. I tried this a ton of times, and until I started with a really big feeding radius and then lowered it over time, even if I gave like other special rewards and tried to get really creative, it just wasn't training. It would just kind of stall out, and it sometimes would run into the baby a couple times and it would be like, oh great, I figured it out, and it learns very quickly from there. And other times it just would never quite run into it, and it would kind of get ingrained bad habits and just would never learn. So this feed radius really seems to help with that. So I'm going to basically lower it down little by little by little until the point where it's at 0.2, which you could lower this down to 0 basically at one point, because we still have that code in there that if it collides with the baby, then we'll feed it. So that's how this works. That's how the curriculum learning works. And we'll pass in this file as input when we train. Okay, it is time to start training. So it's time to make sure that you have your Anaconda prompt up and that you're in your ML Agents environment that you set up using the documentation. You set that up, right? Okay, good. So in your directory here for ML Agents 0.8.2, that's where I've set this up. We're going to use a training command, okay? And rather than type this out, I'm going to use one that I've tested and made sure there's no typos in. So ML Agents -learn, so that's the first part of the command. This is something that's going to start the learning. Then add a space. And then we want to point to our relative location of the trainer config.yaml. Okay, so this config/trainer config YAML for us is inside of config. So we're in this directory right now. So we're going to say go inside config and then find this file. And then we are using curriculum. So we're going to do -- curriculum equals, and then we want to be config curricula penguin. So you're actually pointing to just this folder, because it's possible that you'd have multiple brains that we're training. We might have a penguin and a baby both have brains, and in that case, we would want to make sure that it was training both of those brains simultaneously, and that's why you have this curriculum. It's going to match those brains to their curriculum files. Then we're going to set the run ID, so --run-id equals, and this run ID can be anything you like. So I'm going to point this out. The last one that I did is penguin_15, and I ran the training command on that. So if you go into your models directory after you've run this, I don't think you'll have a models directory until you run this. You can see all of your different runs that you've done. So you can see that I've tried quite a few here. So I guess Penguin 15 wasn't the most recent one, but it was one of the ones that I did. And inside here, you can see the results. Basically, it has a bunch of checkpoints, and it has a .nn file, which is the fully trained neural network. So you want to rename this to whatever you want. So I'm going to call mine something different. I'm going to call this Penguin Final 01 because I'm confident that this will be the final time that I have to train this penguin. And then finally, to finish off this command, you do -- train. So now we're going to hit enter. And it's going to take a sec, but then it's going to spit out some stuff. You're going to see this Unity logo, and then it's going to give you some of the curriculum information and like all these different things that it's going to do. And then it just says start training by pressing play button in the Unity editor. And so you have a small time window that you can go into Unity and hit play. And then let's open this back up. And as long as there's no real errors, like this warning is okay, you'll see that this is starting to train. So he's not very smart yet, and he's going at 100 times speed, but he'll start learning. So now that we know that this is working, I'm actually going to hit play to stop training. And I'm going to show you that you don't have to just do one of these. And in fact, most of the examples, they're training many of them at a time. So we're going to take our Penguin learning area, and I'm going to duplicate it. And I'm going to hold down the control key while I move this, just because I like to keep it snapped to the grid points. And I moved it to like -46. Maybe I'll move it to -50. And that's just going to make sure that he doesn't accidentally see some fish in the neighboring area. And so let me move this academy up. Just don't drop it inside of your other area. Then I'm going to select both of these, and I'm going to duplicate, and I'm going to move them both over like 50. See, I can see the position change to 50. I'll duplicate them again, and I'll move it over to 100, and then I'll duplicate them one last time, and I'll move them over to 150. Okay, so now we have 8 environments that are going to be training simultaneously. We can save this scene. We can come back into our Anaconda prompt, press the up key to get this again, and I'm going to do final_02. And then I'll hit enter. It's going to start off a new training. And then I can press play in the Unity editor. And now all of these are training. So if you switch into your scene view, you can see all of them going at once. And these fans of black lines are actually their raycasts. And because it's happening at 100 times speed, it's actually kind of rendering many of them at once. But they have 5 of them at any given time. And I want to show you what it looks like if you switch away from 100 times speed for a minute. If you go to project settings and set your time value to 1, then you can see what they look like in real time. So this guy's not too bright. He's just running into the wall. But you can see that he's got this fan of 5 different raycasts that he's using to try and see things. That one over there looks a little, oh, no. Well, it's completely random at this point. So we're just going to let it train. I'm going to change this back to 100 and let this train for a while. And then we'll check in on it in a bit. Now I want to point out, we've been training for a little over 105 seconds at this point. The curriculum has already jumped up. So it's succeeded enough times that the average reward was greater than -0.1. So he's learning to get the fish. So that's a good thing. And it's completed 80 different times. So we've jumped up to the next difficulty, which is now a fish speed of 0 and a feed radius of 5. And I want to point out too that we have these penguin learning lines here that basically say, you can ignore pretty much the whole first part of this. It tells you what step it's on. It tells you how much time has elapsed in seconds. So you can just divide that by 60 to get how many minutes it's been running. And then it gives you a mean reward. So that's the average reward that all of the agents got in that time span since the last summary. And then the standard deviation of the reward. So if this is really high, it means that some of them are getting very high scores and some of them are getting very low scores. The smaller the standard deviation of reward is, it means that they're being more consistent. And I also need to point out that when I highlighted this, it froze training. You see that that's stuck, so don't do that and hit enter if you do. And then it's just training. So it's going to keep bumping up the reset parameters as it succeeds and gets better and better at doing this. You can see that it's already learning, like, holy crap, that's really fast. It's learning to just swim in circles and pick up these fish and take it to the baby penguin. And it looks like it's really good, but as soon as it gets past a certain point, it's going to start missing the penguin because it doesn't have that huge feed radius that we gave it in the first place. So that's something to watch out for, and it's actually exciting for me that it's training this quickly. It may not pick this up quite as quickly for you. In previous runs, I think it took me a little bit longer, so don't feel too concerned if it's not picking it up right away. But if it's not improving within the first 20 minutes or so, then maybe there is something wrong and you might need to investigate to make sure you didn't mess up your reward or something like that. Okay, now looking at just this this summary here, every 5,000 steps is helpful because you can see trends and whether it's getting smarter or not. But what you can't see is sort of a nice graph of it. So it's actually quite helpful to see a graph of this, and that's where Tensorboard comes into play. So the command that you need to run from inside your ML agents directory is tensorboard --log dir equals summaries. And summaries is just inside here. It's this folder gets created when you start training for the first time. So I have summaries for every single run that I did. If I hit enter here, then it's going to tell me that I can go to Tensorboard at this address. So I'm going to right click and that'll copy it. If you do Control C, it'll just quit, so that's not helpful. And then go into your web browser and paste this into your address bar. And then you're going to see all of your different runs. So I've run this a ton of times, so I have a ton of these. You're probably only going to have one at this point. So I'm going to click this. This should just hide all the other ones. And you have a few things to control here. So this is going to maximize it, and then this makes it so that it kind of centers it on what it's doing. So this is the cumulative reward over time, and it's smoothed out. You can actually reduce the smoothing here if you want it to be a little bit more jagged and not show you what's going on. I'll leave it around 0.5, whatever. And then, so the cumulative reward is helpful to see. And then the environment lesson is also pretty useful to see. So in this case, it's been increasing the lesson or the curriculum quite quickly. And you can see at what point it did that. So at this point, it did it at 15,000 steps. You can kind of see in this black box that shows up, 15,000 steps is when it jumped up to the next curriculum. Then it jumped up again at 20,000 steps, and then again at 25,000, 30,000, 35,000, and so on. And it still continues to keep doing that. And we can now click this again, and it'll show this. Now I want to compare this to a previous run. So I'm going to click on this. This was a successful run that I did before. And you can see that for some reason, this one is training way better than my previous one. I don't know why that's working. I'm glad that it's working that way in some degree because I'm showing it on video, but just know that yours may not learn as quickly. Like mine didn't even get to an average score of 5 until beyond where this is at. So these are still learning, and holy crap, they are really effective at this. So going back to Tensorboard here, you can kind of see that this thing didn't actually increase its steps at all until it got all the way out here. So this is what I would expect it to be doing, but this thing is just learning so fast that it looks like a straight line, which is kind of ridiculous actually when I think about it. Let's see if I hide this again and click this, then still you can see that it's just so fast. So that's good. It makes things easier for me. And I'll show you an example of one that didn't work really at all. So let me go back down to let's see if I can pick this one. So this one you can see was not good. So it started off bad, and then it was getting a reward, kind of getting toward 1, and then it just flatlined as soon as I changed the difficulty. Now, I wasn't necessarily using the same curriculum when I did this one, but you can kind of just see that as I was experimenting and doing different curriculums and just not succeeding at all, that it really depended on this. This one, clearly I got kind of hopeful and maybe I restarted and did something else. This one flatlined for a long time, and then it figured something out, and then it was pretty successful, and then it kind of leveled off down here once we changed the curriculum. So you can see here, kind of as soon as this bumped up the curriculum, it was doing well, bumped up the curriculum, and then flatlined for a long time, and then it learned a ton, and then kind of flatlined again. So these are all over the place. This is just a helpful way to kind of see your current results compared to previous runs and visualize it in a way that really tells you how well it's doing, which is pretty neat. There are a few other things in here. Losses, policy loss. To me, this doesn't really mean much. It might mean more to someone who spends more time working with machine learning than me. I spend a lot of time doing it, practicing it, but not actually understanding the theory. I have some basic knowledge in the theory. I did take a Udacity course, but I don't really know how policy or losses and policy loss apply to what we're doing. I just know that the penguins are pretty darn good at picking up fish at this point, even when they're moving. So we have moved into lesson 7 at this point, so a feed radius of 2. So we are fully trained at this point, which is amazing, because the last time I think it took me about a million steps, and we can view that again. This one was the last one that I tried, and it wasn't until, let's see, I'm looking at the step count in that black box. It wasn't until about a million that I was like, yeah, okay, we've definitely learned. We're up to the final one here, and it was getting full results. So this one somehow is insanely good at this. So that's great. So once you have this fully trained, which ordinarily you might want to just leave it and go do something else, but it seems to be pretty effective at this. So what you can do is you can hit play and it will stop, and then you will get inside of your models directory, you'll get a .nn file. And we can take this .nn file that it creates inside of the models directory, and for this specific run, make sure you pick the run that actually worked. And we can go into assets, and we'll go into our brains directory, and we will drag that .nn file into here. Now there is a warning in the documentation. They said there's a known bug that if you quit early, sometimes this .nn file won't work. I've found that to be, sometimes that happens. Other times it doesn't. So hopefully, fingers crossed, this one is one of the times when it doesn't happen. If you open up Penguin Learning, here there's a slot for this model. And so we're going to take this model and we're going to drag it in here. Then we need to go to our Academy and uncheck Control. And then when we press play, it will use that neural network. Communicator was unable to connect. And that's because Control is checked. I'm not sure why that didn't persist. So let's do that again. And click play. It checked it again. What is going on? All right. I need to figure out why that's happening. But let's just do ourselves a quick favor. We're going to do this. Hopefully, I'm going to drag this down. I'm going to create a new prefab. And it should save it now when I press play. I don't know. I'm gonna delete this Learning Academy from the scene. I'm gonna drag this one in. Hopefully control stays unchecked. I've never had this happen before, so hopefully it's not happening for you. And click play. And there we go. Now it's working. Control is unchecked. So you can see that he is picking up fish, and then he's heading back to the baby. And it might take him a sec to figure out how to get there. Okay, then it ran into the baby. And he's not amazing at this. If we trained it for longer, it might get a little bit better. But really quite impressive compared to where he was at the beginning. He wasn't learning at all. And now he's learned that he has to pick up a fish and take it closer to the baby. Now we can actually increase the fish speed while this is running. So I'm going to increase this to 0.5. And then the next time it restarts, once he picks up his next fish or once we run out of time here, then it should change the fish speed up to 0.5. Oh, he is going to have to run out of time here. I'll speed this up just a tiny bit. Okay, a lot. And I'll change this back to 1. Okay, so now the fish are still not moving, so I might need to change this fish speed because the Academy clearly didn't reset. So let me play this and let me change the fish speed. I don't know if this is going to persist, guys. I really don't know why this isn't working, but let's see. Nope, it changed it back to 0. Well, in yours, hopefully you can change the fish speed. In every other example I've done, you can change it. This is some weird bug with Unity, I think. But that's the idea of it. So it's working. The fish are being caught. They're being fed to the baby. Let me just zoom in on one of these babies and show you that little heart that shows up once he gets fed. So that one, you can't see the regurgitated fish at his feet because he's kind of in a deeper snowbank there. But this one, we should be able to see it. Where's our penguin? Here he comes. Here he comes. Oh, there we go. So there it is. There's our working Penguin ML agents. And of course, you know, if you wanted to apply this to a game, then you wouldn't want 6 of these running simultaneously. You would probably put this penguin into its own scene and have it hooked up with that trained neural network and then just have it explore and see if you can get it to work in other scenes. All right, that wraps up this video. Thanks so much for following along. I know it was a long one, so you had to have some real perseverance to get through the full length of the video. If you enjoyed it or if you didn't enjoy it, let me know in the comments. It's always helpful to get feedback so that I can improve. I'm planning on making more content like this, but if you want to kind of guide the direction of what I create next, then make sure to let me know specifically what you'd like to see more of or less of. I'm going to work on a course starting after this video, I guess, that's going to cover ML agents in a bit more depth. The plan is to not just create a project, but create something that is a finished product. So a game that you can play with and actually maybe publish to a marketplace for games and have your own game out there that uses AI or machine learning. So I think that'll be pretty cool. Make sure to subscribe here, or you can follow on Facebook or Twitter or wherever else. I'm posting all over the place. And I'll let you know when that's available. Thanks so much.